Look at a second example here. In this case, we've got another design situation where we have a shed that's 15 feet wide. We know that one rafter makes an angle of 30 degrees with the horizontal on one side of the roof, and a rafter on the other side makes an angle of 80 degrees with the horizontal. So we want to calculate the length of the shorter rafter to the nearest foot. So again, first thing that we want to do is actually draw a diagram. So everything's relative to the horizontal, so we'll draw a horizontal line. And then we know that the shed itself is 15 feet wide. So this side is 15 feet. We've got a short rafter and a long rafter. So one rafter, we'll draw a rafter like that and a rafter like that. So one rafter is 30 degrees to the horizontal, so we'll say that rafter is 30 degrees, and the rafter on the other side is an angle of 80 degrees. So we'll say that this one is 80 degrees. And we want to figure out the length of the short rafter. So in this case, the length of the short rafter in our diagram is going to be right over here. So the length of the short rafter is always the side across from the smaller angle. So that's going to be this piece here. We want to figure out the length of that particular rafter. So let's label this triangle. We'll call this A, B, and C. So we're actually trying to figure out the length of C. Okay, we don't know the length of A. We do, however, know the length of B. Okay, so if we're going to do this problem, we have to figure out, well, which trig thing do we use? Do we have a 90-degree angle? No. So we can't use a primary trig ratio. Do we have a scissor pattern in order to use the cosine thing? Do we have, for example, a side, contained angle, other side? Well, no, we don't, because we don't know what the value of the side A is. So we can't use cosine law. So can we use sine law? Well, we have two angles and we have a side length. But because we have two angles, we can actually figure out that third angle. And that will allow us to have a complete side angle pairing. So let's figure out what angle B is. So angle B is going to equal 180 degrees minus 80 degrees minus 30 degrees. Okay, so angle B is actually going to equal 70 degrees. So we now have a complete side angle pairing. We have a key. And because of that, we can now use the sine law. So knowing that we can use the sine law is going to allow us to figure out side C. So we know that we've got B. We're going to write out the sine law for B, because side B and angle B make up our complete pairing. And we know that we're trying to figure out the length of C. So C over sine C. So now we're going to substitute in values that we know. We know that B is 15 feet. The length of B is 15 feet. We know that angle B is 70 degrees. We don't know what the length of side C is, but we do know that the angle C is 30 degrees. So we've got sine 30. Okay. So what we're going to do is we're going to go through and we're going to use our cross multiplying skills. So I'm going to multiply 15 times sine 30, which will be equal to C times sine 70. So I've got 15 times sine 30, which is equal to C times sine 70. Okay. Now I need to get that C value all by itself, and right now it's being multiplied by sine 70, so the opposite operation is to divide both sides by sine 70. When I divide both sides by sine 70, that means that on the right-hand side of the equal sign, the two sine 70s cancel each other out, so I'm just left with C. And on the left-hand side, I can multiply 15 times sine 30 divided by sine 70, which will give me approximately 8 feet. Okay? So therefore, the length of that third rafter, or of the short rafter, is approximately 8 feet long.